Hello. So a quick question into the audience. So who of you knows what is the graph? Okay, we can do some introductory then. Who already wrote the subgraph? Okay. And who already wrote the smart contract? Okay, now better. And who plans to write the smart contract? Cool. All right. That's that's good. Okay, that's good. All right. So my name is Simon. I am a solutions engineer at ETHNode. That's one of the core dev teams that work on the graph protocol. And and tonight I show you how to use the graph. And this time I think I start this presentation with this is what you can get. Like if you use the graph, we have two tracks. The one is a best new subgraph. That's the first thing we will look at. The best one will get $2,200, runner-up $800. And then you can also use existing subgraphs. There are tons. I will show you where you find them. And because this is much easier, the bounty is a little bit lower. So I would say the strategy here is if you are a good developer and you want to go for the higher bounty, then you would do that, but it takes more time. Whereas when you use an existing subgraph, it might be more competition. But yeah, let's see. The thing is, a lot of hackers usually start with this one, Remix. Who uses Remix for the smart contract development? Yeah, and especially the beginners first use Remix before they start to use more sophisticated tools like Foundry, Hardhat, and that kind of stuff. That's why I show you quickly how you do it in Remix. So when you are in Remix, what you usually do is like you create a new workspace, and then let's say we create an NFT. NFTs are cool, maybe it's almost a little bit over, but yeah, we can still do one. And so it's cool, so you can just start with a template, and then you can say, okay, I want a mintable, burnable, posable, yeah, whatever. And this we don't need, upgradability. I believe in smart contracts should, if possible, be atomic and non-changeable. Huh? Cool, and that's it. Then you just click OK, and then it generates you this token. You have these functions, so you can pause it, you can mint it, and it's using the Open Zeppelin standard, so that's already good. So I can say like, yeah, this is now the Simon token, ST. And when I save, it compiles in the background, it creates all this stuff. But actually, at some point, you are finished, and then you want to deploy it. So let's go to Girly Network. And you will just say, okay, I want to use the injected provider, and then we deploy. You sign the transaction, and it deploys the contract. So now you already have your contract deployed, almost there, right? It's Sunday morning, and you think like, okay, I want to build my front end on top of it. I don't know who tried to get data from a smart contract with the JSON RPC providers, but in my opinion, it's a bit a mess. I can show you. It looks like this. So you write code that you loop over, you do these callbacks back and forth, and try to get it. And when someone has 10 NFTs with that code, and that's code that I saw in the wild actually, and all of these calls to the JSON RPC endpoints that take 200 to 300 milliseconds, you easily end up with 3, 4, 5 seconds load time of your website, right? I mean, that's not cool. So we have the contract now deployed. That's very cool. So what you do next is you verify the contract. It's very important. I never interact with any contract that's not verified. I mean, you never know, right? So how can we use this in Remix? So there is a plugin called the Flattener. So if you're here and you don't find it, you just do the Flattener. You click on Activate, and then you go here, and then you just say like, flatten my contract. And now, immediately, the whole flattened source code, that means all these imports are created in one file, are in your clipboard. Then I can just go here, and it works actually more or less the same on any chain. So you can do this on Polygon, on Mainnet, on Mumbai. You just say verify and publish. Then we have the contract address here. Compiler type is Solidity single file. The compiler version is usually 8.0. You can check here which one it is. Right. Open source license MIT. And then we go forward. Paste just the code that we have in the thing. You prove that you're not a robot. Oh, boats. All right, verify and publish. And then your smart contract will be verified. Nice. Cool. And now you're actually ready. Oh, cheat sheets. Can I? So she has cheat sheets that help you with these steps to remember. So please raise your hand if you want one. And now the next step is you actually now want to have a subgraph. So you have a smart contract, it's verified, and we now want to have a subgraph that I can use. We want to have a cool, a nice GraphQL API. I want to have something like this. I want to have a GraphQL API that get my data out. That's very beautiful. All the front-end developers know that's the way to go. All right. So what do? I go to thegraph.com. Oh, wait, other browser. Thegraph.com. When you are on Gurley or in Ethereum mainnet, you choose here Subgraph Studio. If you are any other chain, Polygon, Mumbai, Celo, whatever, Optimism, you go to hosted service. But because we are on Gurley, we take Subgraph Studio. So I go here. Usually you connect first. I want to show you all these steps. So you connect, you take MetaMask, pop-up comes, you sign in, you sign, that's it, you're here. Now you create, and then you say, I want to actually make a subgraph. So you create the subgraph, you say which chain you are indexing. It was Gurley, so Gurley. How do I name it? I name it NFT. Nothing special. All right, continue. That's it. Now when you are here, there are like instructions what you should do. It's the same on the cheat sheet. So you should install the Graph Protocol CLI globally, and then and then you can actually say graph init -the studio Simon's NFT. That sounds interesting. So let's do this. Now, here comes the trick. I wrote it also on the cheat sheet. But the trick here to get started quickly is like -- index -events. All right. This is the magic thing that helps you to get started quickly. All right, now let's do it. Now we have a nice dialogue that we can go through, and it says, which protocol do we use? The graph supports Arweave, Near, Ethereum, think of EVM compatible, and Cosmos. But we are here with Ethereum. It's a ETHGlobal hackathon, so Ethereum. The subgraph slug, it's already here. We can just take it. Then the directory, that probably sounds good. Then I check the network. I take Gurley, right? And now I need the contract address. The contract address is here, this one. You can just copy and paste. I hope that this will work. I'll check. Okay. Let's just try again. Yeah, all right. Sometimes you just need to try again twice. So it takes some time until the API is available on EtherScan, but yeah, like if it doesn't work, there's this thing like, if it doesn't work, turn it off and on again, right? Okay, so it's Simon's NFT. We give just a name, and boom, the subgraph is created for you in the background. Now, we actually don't need to do much. We don't need to understand how to write the subgraph, how this works, what is a schema, what is whatever. When we want to get started, we can just follow the instructions here. So you go into the directory. You can do this in a new window while it's installing. Then we actually do the authentication. So we need to load the API key that we can deploy. So I do this. And now the deploy key is set. And here, now in the background, everything is already installed. It asks me if I want to do another contract, but we are good. Like, just go with this. That's it. And now I can just say graph deploy. Actually, I need to change here. And I can just graph deploy to the studio. I just followed these steps that are written there, which are also on the cheat sheet. I return. I need to give a version label. Let's say it's 1. And boom, it's deployed. That's it. Now I can go here. And go into this URL. And here I have a GraphQL interface. Now, unfortunately, currently we have this problem that if you just follow the steps that I did, there is one small missing piece that we can now do together. I mean, eventually this subgraph will start to index, but we can speed it up with this little trick that I show you right now. So we just look at the code. And the subgraph, basically, the main thing you're interested in is the manifest, like the subgraph YAML. So here the trick is everything is already set up for us, but what we need to do in source, like we need to add a start block, so that the graph node in the studio knows where to start indexing. How do we find the start block? We look at the transaction where the contract was deployed, and we check the block, and we just copy paste. All right, boom. Save, and redeploy. Now it's version 2. All right, let's see what the studio now thinks about this. Woohoo, it's fully indexed. So that was better, right? Now we can also go into this again. There's also the playground. So what is probably interesting with NFTs, we see transfer events, right? So the playground is cool because it helps you. It has here a GraphQL Explorer. So we don't really need to understand everything. So you can just click around here and say, actually, I'm interested in the transfers. And maybe I want to have the from, the ID, the to, and the token ID. And then it just builds you the GraphQL query. You don't even need to understand GraphQL in detail. But when you have a front-ender in your team, they know, right? And then you can send it. And ooh, we do not have any transfers. But I mean, it's a fresh contract. If you're in Remix, it's very easy. You can just go, where is it? Here. This one, thanks. I'm not using Remix usually, but I need some help. So what I can do here is save mint. So I can just say, okay, I mint myself an NFT, copy the address, take a token ID, and then send it. Boom. And check on EtherScan if it comes through. Probably takes a while. Cool. So this is the easy thing. So you can quickly get started with a subgraph. You don't need to know much about it. You can just follow these steps. I repeat, you go to Remix, you deploy a contract, you verify the contract, then you go to the Graph Studio or hosted service, then you log in and create a subgraph, and then you go into the terminal, and very important, here is this, where is it? This one, graph init -- index events, and that will scaffold you a subgraph that has for every event on your smart contract an entity and auto-generated mappings, and you can just get started. I think the transaction should be included. So we go now back to the Subgraph Studio, we send the query again, and we see our transfer event here. It's very easy. Now, you are already get started. You have like a contract deployed, you have a subgraph, you have a GraphQL interface. Now you just need to code a little bit front end and you're actually done. You can go home and enjoy maybe Saturday night parties here in San Francisco. But yeah, there's probably more. And we can go into this. So for those that don't know what the graph is, I give you quickly the theory behind now that we saw the practice already. So when you think about the data on chain, we currently have a state. In the thinking of NFTs, you can think about this Google Sheet where you have like a token ID and an owner. So the blockchain always knows who owns which NFT. But what about the provenance? Who owned the NFT before? So we know that the blockchain is this thing with the transactions on top of each other, and so we should know, but it's not easy to get to the old data. You need to kind of dig through it. So, and it would be nice to have this time machine where you can just go back in time and then you see how this owners changed. And that's actually what the graph helps you with. So initially the idea for dApps, like these decentralized applications, was that you have a front end that's JavaScript, HTML, and CSS deployed to IPFS or another decentralized storage, and that directly communicates with the blockchain. The problem here is the blockchain is optimized for writing. You pay the miners so they introduce your transaction. But like when you read from the blockchain, how does this actually work? I mean, in theory, you can communicate with a node that you should run at home. But a question like, who runs an Ethereum node at home? Yeah, some. Yeah, you can communicate with that node, but the JSON RPC interface that you communicate with it, it's not actually made for building a front end. It's made for you managing your node and maybe send a transaction and do some inspections. And also, there is no incentivization. If you don't run the node by yourself, like who gives you that data? I mean, sure, there are like some centralized providers that give you access to JSON RPC endpoints, but that was not the idea of a decentralized system. So you end up with stuff like this when you get the data out. So what a modern dApp architecture would look like is you have a front end that writes to the blockchain. That works, that's cool. And then when you want to read data, you go through an indexing protocol like the graph that gives you decentralized access to data. Now the graph network is already live since 1 year for Ethereum mainnet, and you can have fully decentralized subgraphs there, the thing that we built before. And the thing is, you pay per query. By paying for queries, the incentivization structure for the data delivery is given. Yeah, so that's the graph. You know, the APIs for this decentralized future. Oops, where are we? On the host service, the graph currently serves 1 billion queries a day. That's quite a lot. And you know, big user like Uniswap, Audius, Unlock Protocol, and others using it. Teller also, actually. But those two already are on the decentralized network. And now, since 1 year, we launched the decentralized network. You have 224 indexers worldwide. They're independent. They index your subgraph, and they're participating in the network with incentives. They receive query fees. They receive indexing rewards. And that makes it redundant, right? If one indexer goes down, another is around to serve your queries. And so that gives you fast, cheap, and reliable APIs in a decentralized way. And that brings us together through a global open API where all the data is available and for you. Yeah, so we can have truly decentralized apps. We quickly touched the subgraph. So basically, all these transactions are a mess, you know, on touch of each other. And a subgraph creates these focused databases, if you want, that you can say what you want in your database. So if you write a subgraph for your specific contract or your protocol that you write on this weekend, then you just say like, okay, I'm interested in this contract and interested in this event and that transaction. That's how I want to store my data, and then it will be there. Otherwise, it will be very hard to get that data. So you have full control over which data you want to store and how you want to store it. And then later on, you can just query it. So this is roughly how it works. So the dApp on the right side, we saw this. We write transactions to the blockchain. The blockchains get in. They emit events in what for NFTs, these are transfer events. They are emitted, and then the graph node is configured to index those events or to ingest. Then you run a mappings code that you also can enhance. If you want to get the prize for the best new subgraph, you should really enhance your mappings and not just do this, what I did, but it's a good starting point. It will be stored in a database. So on the other hand side, on the left side, you see you send queries which go to this GraphQL API and will be served by the graph node. That's roughly the system architecture here. yeah, that's actually then how it looks. So you have this mess of subgraphs, data, and in the end, magically, it gets ordered, and you have a very good overview of what's going on. Cool. So now, if you want, you can scan the QR code and tweet that you just learned about the graph. Or not. All right. So you want now peer pressure starts. Cool. Yeah, we did this already, the subgraph stuff. But actually, we can now go a little bit into the code. So we barely touched on the subgraph YAML, that this holds it together. In the subgraph YAML, you define which chain I'm interested in. What is the address that I want to index? What's the start block? What is the ABI? You see the ABI is copied here, that was created magically for us. And also, which event handlers that you are interested in. So because we use the ownable, posable, whatever event handler, Open Zeppelin templates, you have all these events here. But for NFTs, you're mostly interested in a transfer. So that's the YAML. The YAML also says where is the schema. So the schema, when you look at the schema, it's really just defines a database. You say, okay, there is one table with approval, and approvals have an ID and owners, which is represented as a bytes, and approved and token ID. And so this is all just auto-generated according to your contract. But you're free to change this, right? So you could say, yeah, actually, I'm also interested in the block number. So you write block number, and say it's a big int, and then you can extend your subgraph from here. Then the third part is the actual mapping. So the mappings, they are written in a language called AssemblyScript. It looks similar to TypeScript, but it has small nuance differences. So for example, you cannot just import JavaScript packages here. You only the AssemblyScript stuff. But yeah, it's pretty cool. And because, for example, VS Code knows about, you can also start to explore. So we can see, for example, what is then in the event? What do we have here? And I do usually this command click, and then you see you go into the event, and then see, okay, it's an approval event. These are the properties. I can also see what is actually here, what is in an Ethereum event. Then I see, oh, there is a transaction, or there's a block. Let me see what's in the block. And then we see, oh, okay, we have the block hash, timestamp, and so on and so forth. So then I could say I added this block number here. What you would do as a next step is you just do yarn code gen. When you change the schema, you need to run code gen again, which generates this stuff. And then I go here to handle transfer and make entity. So the block number, and see now, because I did code gen, it already knows that the entity has a block number equals event. That's also we explored before. On the event, we have block, so I type B, and you see, like, you can explore it here. It's not so complex. Number, that's it. And I can save, and I can redeploy. Now version 3. Cool. So that's roughly how a subgraph works, and how you can extend it and really, build your magic. You can come up with new entities that make more sense, not just the events. For NFTs, for example, you want to have the holders, the actual NFTs, then maybe the sales, or whatever. It's up to you. We are already almost at the end. What I want to show you quickly is this QR code. This time it's not for a tweet. This will bring you actually to a repository that I created for this hackathon that has all the example code, a link to that presentation, a link to the cheat sheet. So if you rather want to have it digitally, and yeah, and more. So really a good starting point for a hackathon focused. Also, if you go there, you see I have. Oh, you need it back? I also added some interesting stuff for you. and especially the good subgraphs. So here is the trick. When you are on a hackathon, you want to get as much bounties as possible for different sponsors, right? So that's why they sponsor. And an easy thing to do actually is you go you look for the subgraphs of the sponsors that you're interested to build upon, and then you use that subgraphs and you make a cool integration. If you do a cool usage with the special stuff, maybe you do some machine learning on top of it or whatever, then you come into a good position to get the best usage of existing subgraph. So I have here, so for once, we have the Messari subgraphs. It's very high quality. Messari joined as a core dev for the graph ecosystem, and they are writing standardized subgraphs over these different verticals. So we have for exchanges, ERC, governance, and they all have the same schema. So you can aggregate and compare and do fancy stuff. So you can click on those, and then you are you find the links, and you can also inspect. You see events and they have some charts. So that's very good, the Messari stuff. But also other sponsors, for example, Lens Protocol. I know they have their own API, that they have their centralized API, but there is also a subgraph. And so if you want to build something on Lens, you might want to check out that subgraph and see how far you can get, because if you have a good application on top of the Lens subgraph, you might be eligible for both the Lens and the graph bounty. And so it goes. Also Unlock Protocol, which we'll see later. Here, OpenSea, that's a sponsor. Linear, as an example, how a subgraph on Near works. Very interesting. Aave Gochi, a cool subgraph that's on Polygon. Yeah, so you can check this stuff here. Yeah, I think I'll leave it here. We are at the booth. I try to be there as much as possible. And so if you have any questions, just come by and we look at it together. And if you have any questions now, I think I have another 2 minutes to answer questions. So please shoot them. Thanks. Yes? Good question. All right. So the code, the mapping code, it takes a while to run it. It depends on how efficient you write it. So rule of thumb is do not do if calls, do not call back if possible. But usually it's a matter of milliseconds. Like if you do not do very complex stuff. So you saw before I just created that transaction, the block gets mined, and then more or less half a second later, you have it in the subgraph. And if you want to know which block that your subgraph has indexed, there is this special thing here. So we had transfers. It's the meta key. So with meta, block, timestamp, and number that you can query for. Oh, I created a new version. All right, let's do it again. Meta, block, timestamp, number. You see, this is the latest block that the graph nodes are, or the subgraph, and this is the timestamp. So that helps you to build a front end that knows how fresh the data is. One more question? Otherwise, yeah? Yes. When you send a query, they respond to that query and they give you a query attestation, and they have GRT staked. So if they give you the response and it was wrong, you can prove them wrong. There are also fishermen that observe this, and then they get slashed, and the fishermen get part of the slashing. And but we're working on a thing called verifiable queries, so that you will have a proof that everything is true. I mean, this is a little bit hard mathematical problem. But that's on the roadmap. Thank you so much for having me, and yeah, happy hacking.